Thank you, Maria. I'm excited to be here, and hello everybody else at Percona Live. Presume you can now see my screen.
Yes, we can.
And yeah, great. So I'm here to give you a quick talk titled Expert MariaDB on how you can utilize MariaDB Server more efficiently. As already introduced, I was on the founding team of MariaDB Server, formerly of MySQL. Currently, I have relationships with Codeship and Proxy SQL, and done a bunch of things, including winning an award 6 years ago. So a quick note for today, in the sense that this was actually initially designed as a 3-hour hands-on tutorial, but due to the cancellation of Percona Live Austin, we can't exactly do a 3-hour hands-on tutorial. So it was actually going to be taking a fairly simple Oracle app and basically migrating it to MariaDB Server and then going into trying out the new stuff. But today we'll just focus on a talk of what you will get from MariaDB Server, especially if you're coming from MySQL. But also it will benefit you if you're coming from other databases. It doesn't cover the basics of MySQL naturally. So if you're coming from, say, Oracle or something, that might be a bit of an issue. It's good that we also just recently had a new MariaDB 10.4 release. So you'll note that the latest GA came out on 15th of May, sorry, the 12th of May, 2020. And there was also a 10.5.3 release candidate on that same day, which can mean one of many things, that you will probably see a generally available release in June before the 10.6 planning and development happens to start and continue. So what is MariaDB Server? I've actually pasted two variants here, and the reason is because the new change is such that it is now stated it's originally designed as an enhanced drop-in replacement for MySQL. It was previously said that it is an enhanced drop-in replacement for MySQL. It turns out that MariaDB is, of course, quite different nowadays to what it used to be. The first GA release happened in February of 2010. So MariaDB is officially 10 years old now. And MySQL is also celebrating its 25th birthday, sort of in about 3 days. So happy birthday, MySQL. 25 is a big year. But MariaDB has been around also for quite some time. So it is no slouch. In fact, the first ever beta release came out in late 2009 when the project officially started. So for completeness sake, yes, there was also a Percona variant of MySQL 5.1, but you'll notice that MySQL 5.1 spawned 3 variants of MariaDB, 5.3 being maybe one of the more interesting variants, where it had a lot of optimized and replication changes. MySQL 5.5 and MariaDB 5.5 were very lengthily separated in terms of release. It was a delay of some 16 months, give or take. Whereas Percona Server 5.5 managed to come out reasonably quickly compared to MySQL 5.5. At which point it was decided that there should be no MariaDB 5.6, because the key here is to be able to continue being independent of Oracle release schedule. At which point you start noticing that 10.0 came out first, 10.0 came out first, 10.1 came out first, then 5.7 came out. Well, 10.1 and 5.7 was separated by a couple of days. Then 10.2 came out, then 8.0. And since 8.0 has come out, we've also seen 10.3 and 10.4. And we are very much likely to see 10.5 come out before the next version of MySQL comes out as well. So you're starting to see a much more rapid release cycle. The idea is everything comes out within 1 year, and then it goes on to the next major release. Now, it's interesting to take a look at releases and time lags because you can notice that MariaDB server is on a once per year cadence. You will notice that when it comes to 5.6, the gap for creating a Percona server was 8 months. 5.7, the gap was only 4 months. And for 8.0, again, the gap was 8 months. But the delta nowadays with MySQL changing so much in the 8.0 point releases, the minor releases, you'll notice that 8.0.19 Percona had a 2 month delay, 8.0.18 a 2 month delay, 17 a 3 month delay, 16 a 4 month delay, 15 a 3 month with two releases. So I think the one thing that's kind of important to note is that MariaDB is clearly at this stage a fork of MySQL, and it is its own database, whereas Percona Server is still very much a branch of MySQL. And the one thing that MariaDB is not beholden to is this idea of rebasing. You can make releases just by cherry picking stuff without ever having to worry about what goes into the server. But it also makes comparisons much harder, and it also makes and also with the fact that MySQL keeps on adding new features into minor releases, also makes it much harder for us to actually make comparisons. So, good examples are things like flushing SSL, check constraints. They all appeared after 8.0 became GA. And I think that's very good that development is not dependent on Oracle release cycles. In fact, you'll notice that even in cloud providers, you're starting to see Amazon offer RDS for MySQL and MariaDB. You see the same thing for Azure database on the Microsoft Cloud for MySQL and MariaDB. Alibaba also has similar for MySQL and MariaDB. If you download the latest version of Red Hat Enterprise Linux 8 or CentOS 8, you'll notice it provides both MariaDB and MySQL, as opposed to Red Hat Enterprise Linux 7, which actually removed MySQL for the focus only on MariaDB 5.5. So these are all relatively interesting when you start thinking about it. Is that initially the goals of MariaDB were to be a drop-in compatible replacement, but now it really is it's a database of its own. But MariaDB is also more than just a server. The MariaDB Foundation basically has MariaDB Server, GPL v2, plus Mariabackup, which is a branch, fork of Percona Extra Backup. In fact, it allows you to backup and restore tables using data at rest encryption. It also works with InnoDB page compression. The SSD method works with Galera Cluster. It works on Microsoft Windows. So if you happen to use MariaDB on Windows, this is also not a problem. And they can also do backup and restore of tables using the MyRocks storage engine as well. So you don't need to use a separate backup tool. There are also obviously these connectors, basically for their LGPL license. So great, even if you wanted to embed these connectors, they are available for C, Java, Node.js, as well as ODBC. And if you look very carefully, work is being done on a Python connector, a C++ connector, as well as R2DBC, which is the Reactive Relational Database Connectivity Project that brings reactive programming APIs to relational databases. So MariaDB is creating a lot more connectors that are native to work with MariaDB. Of course, the corporation also offers something called a Platform X4, and that one consists of MariaDB MaxScale, which is business source licensed. So probably don't have to go too much into that on this slide, but maybe on the next one. There's also column store, which will allow you to then execute this idea of a smart transaction. So when the transaction comes to MaxScale, it can decide, should it go to the row-based MariaDB Enterprise server or the column-based column store? And the choice is really defined by the proxy, which is MaxScale in this situation. And of course, it also includes MariaDB Enterprise Cluster. And you may be wondering what would be different there from a regular Galera cluster. And one of the main differences is that the Gcache can also be encrypted with MariaDB Enterprise Cluster. And of course, there is also this thing called SkySQL, which is the MariaDB cloud that you can now access. It'll provision with Google Compute platform as well. And documentation still remains as part of the knowledge base hosted at the corporation website. And there's also another product called Clustrix, but it comes with a different sounding name. It's not integrated. In fact, the only reason I've included column store on this slide is because column store will be fully integrated into MariaDB 10.5. It is already available in 10.4 Enterprise Edition, but we're only going to focus on the open source stuff here in this talk. Licensing, of course, totally matters. MariaDB Server is GPL v2. MaxScale's got a business first license. Column store is GPL v2, but all the interesting tools around it are business first licensed. And a good example of the MaxScale BSL is such that it tells you that you have this additional use grant where you can use the license work when your application uses MaxScale with a total of less than 3 server instances for any purpose. So if you're trying to run a Galera cluster, this may not be great for you. And it's also worth noting that in point releases, the licenses have changed, basically going from 2 years to become GPL v2 to 4 years to becoming GPL v2. So this means getting licensing fees for quite some time. One thing I'd love to focus on is the fact that now you have these MariaDB commands. So you don't have to type MySQL to log on to MariaDB. You can also just type MariaDB, and you'll notice that they're all actually symlinked. So things like MySQL admin is now known as also MariaDB-admin. MySQL binlog is MariaDB-binlog. So this is taking away from any kind of confusion that this is the same database. It actually helps that you can also have these commands, because the MySQL binlog tool, if you get it from MySQL, will not necessarily work on the MariaDB variant, and vice versa. So I think this is actually overall a very, very, very smart thing. When it comes to replication, you should be able to attach MariaDB replica to MySQL primary without too much issue. In fact, there are, of course, this chart here that I took from the MariaDB.org website. It's currently missing a bit of information on the MySQL 8 being attached to 10.4, but I have tried this and it does work. So it is actually fairly easy to migrate to MariaDB Server, but it is harder to migrate away when you're using replication. You should be able to do a dump and restore, but this is something you should keep in mind. There are also other very interesting things about MariaDB's replication. So for one, MySQL by default has chosen for you to go and use a row-based replication in MySQL setups. Whereas with MariaDB, the default format is now mixed. Now, this means you have to set the default format to row when you start turning on Galera replication, because Galera replication, write-side replication requires the use of row-based replication. Then there's also the default replicate, annotate row events, which is also turned on by default, which means that when you do have binary log being sent to you in a row-based format, it'll also annotate the statement on the top of it as well. This, of course, can lead to larger binary log files. And maybe this can be mitigated with binary log event compression, but it's also now something that you can find in MySQL 8.0.20, which was released not long ago. So binary log event compression has been around in MariaDB for many years now, and but it is also available in MySQL. Time delayed replication I choose to show you here is also because it was available in MySQL 5.6, so a few years earlier than it appeared in MariaDB 10.2. But for all intents and purposes, having a time delayed replica is basically the same. Restricting the speed at which slaves secondaries can read the binary log from the master or the primary. This is also something that's available in MariaDB. The idea to do DML only flashback, which allows you to roll back instances, databases, or tables to an older snapshot, comes from Alibaba. It's additions to the MySQL binlog tool, and it's something I would say is still unique. And you can selectively skip replication events as well. which I'd say is still relatively unique. Now, MariaDB supports 3 types of replication out of the box. They are asynchronous replication. They are also semi-synchronous replication, which is not as a plugin, might I add. It is actually as a full-on built-in into MariaDB, and it also supports a virtually synchronous replication via Galera Cluster, also built in. So there are 3 types that you get, and they are well worth considering that they all exist, and you can use them simultaneously, side by side. I mean, you could have a Galera cluster with asynchronous secondary as well. This is not a problem. Now, this is an example that I've picked up straight from Debian. Debian allows you to have these installs which are interactive. Dpackage allows interactive installs. And MySQL, if you install it now, will tell you, hey, we're going to use something you call SHA-256, caching SHA. It doesn't use caching SHA-2 password, which is based on SHA-256. It doesn't use MySQL native password any longer. And this means that if you come from MySQL 8 and try to go to MariaDB, you're going to have a problem because MySQL prefers a caching SHA-256 password, whereas MariaDB still uses MySQL native password. MySQL obviously previously had used SHA-1 base auth since version 4.1, and then after that, authentication became part of MySQL native password. Computers became faster, so you got new attacks on SHA-1. And SHA-1 is no longer considered secure as it was in 2001. Also, don't forget that these MySQL native passwords like double SHA-1. So Ed25519 was created, which is based on an elliptic curve digital signature algorithm to securely store users' password and to authenticate users. Same algorithm used in OpenSSH by same code by Daniel J. Bernstein. But in MariaDB, it's still MySQL native password by default. But you can choose to use Ed25519, but there is no caching SHA-256 password at the moment. So they are incompatible with each other. In 10.4 and greater, Unix socket authentication is on by default in Unix-like systems, which means that if you just install MariaDB and you type MySQL, it will just work if you are the root user. And also you can have more than one auth plugin assigned to each user. So you can have MySQL native password at 25519, as well as Unix socket auth for one user. This is kind of useful because everything MariaDB tends to be chain loaded. So this is chain loading users with multiple auth methods. There is also the ability for you to do chain loading of password plugins, which we'll talk about later. So yeah, it's quite reasonably useful. There are also some security differences, such that you have the validate password plugin on by default in MySQL 5.7 to ensure you have a more secure password by default. However, this is not available inside of MariaDB. Then there is also it is available, but it's not turned on by default. So that's important. Then of course there's a simple password check, which allows you to enforce a minimum password length and guarantee that a password contains at least a specified number of uppercase and lowercase letters, digits, and punctuation characters. And there's also cracklib password check, which will be making sure that the password is strong enough to pass the cracklib password check. So you need to install it via PAM cracklib. You can chain load simple password check as well as cracklib password check. Authentication with a PAM-based backend and Kerberos JS API-based backend also is available. One important change is that things like accounts and passwords and global privileges are stored in the MySQL global priv table. User table still exists, but it's now just a view that references the global priv table. Things like account locking and unlocking exist in both MySQL and MariaDB, as well as user password expiry also exists in both. MariaDB, of course, has a bunch of enhancements that you should be aware of. For example, MySQLD for MariaDB also reads the MariaDB part of a MySCNF file. It also reads the Galera part, the MariaDB 10.4 part. So you can actually give version numbers and different versions of MariaDB server will read options for that. So you can actually have a very large my.cnf file if required. Also, things like extended slow query log statistics, it's based on the micro slow patch, is available. All kinds of error numbers for MariaDB start at 1900. There are about 86 different error numbers that MariaDB has, and you can find this also via the p-error tool. When you do show process list, you actually get this thing called progress reporting. So it actually show you the progress of how long things are going to take. This is a pretty good thing from a DBA standpoint. In fact, you get a lot deeper process list because you will notice that you have things like time in microseconds, the stage, the maximum stage, the progress, how much memory is being utilized, how much max memory is available, what the examined rows are. All of this is extremely unique to MariaDB with the extensions that MariaDB has applied. So on the left-hand side, you're seeing basically what MariaDB shows, and on the right-hand side is what MySQL 8 shows. And you'll see that they are actually pretty different. So what is progress reporting? Basically, it allows you to do queries like, I'd like to know if it's going to take me, a couple minutes, or maybe even a couple hours to do a alter table or a load data in file. When you couple a load data in file with, say, maybe you're trying to load, 100 gigabyte table. Well, okay, let's not go 100. Let's go 10 gigabyte that dump file into a Galera cluster, and you can do this now with a streaming replication in MariaDB 10.4, which we'll talk about much later. If you're trying to do that, it'd be great if you knew the progress reporting as well. So that's something that's available inside of MariaDB. MariaDB obviously has a few other enhancements available. Table elimination, which is like, kind of like the basis of anchor modeling. So the basic idea behind table elimination is that sometimes you can resolve a query without even accessing some of the tables that the query refers to, especially when it's very highly normalized data. So one can invent many kinds of such cases. So this is really mostly for highly normalized data, and it's been around since MariaDB 5.1 actually. So it's so it's been around for many years, and it's not made its way into other servers. Dynamic columns basically allows you to store different sets of columns for each row in a table. It works by storing a set of columns in a blob and having a small set of functions to manipulate it. And this is also reasonably unique to MariaDB. There's also column compression, which allows you to compress columns. This is something I believe is also available in Percona server with dictionary support, but it is definitely available inside of MariaDB. It has proxy protocol support in MariaDB. So when a client connects to MariaDB via proxy without the need to define user privileges based on the host of the proxy protocol will allow the proxy to provide the client IP address to the server. So with the audit plugin, you'll actually log client IPs as the real client IP and not the proxy IP. And this is a extremely handy feature that's available inside of MariaDB. If you're using MyISAM, you can actually turn on the segmented key caches option. I don't know how many of you are using MyISAM still. In fact, there is no good way for me to to figure that one out. Something we can do when we are in a room together. I can ask you, hey, do you use MyISAM? But now we'll just offer you this option. And actually, you can mitigate the thread contention for the key cache lock with notable performance improvements. And the key caches are divided into different segments, allowing for much better key cache concurrency. So you can set this to anywhere between 1 to 64. And there are benchmarks for this available at mariadb.com. And then if you are thinking about the instant add column feature that's been available in both MySQL 8 as well as MariaDB, there is also now an instant drop column available in 10.4. So So these are all very useful enhancements from a user standpoint. Usernames can go up to 80 characters long and roles up to 128 characters long. And it is worth noting that MySQL usernames are limited to 32 characters, and the old limit before was 16 characters. MariaDB still ships a thread pool. It is obviously an open source thread pool. It, in fact, even gets enhanced in 10.5 further. So this means you don't have to go buy an enterprise subscription to use a thread pool. It also has a SQL error logging plugin, basically allowing you to log SQL errors into a file. So if these are errors that are served to the client, they actually get sent back into the file. There's also an audit plugin, again, not something you require an enterprise subscription for, and you can use it fairly extensively. In fact, if you use Amazon's web services, they also do actually focus a little bit on the audit plugin that comes out of MariaDB. It's been an asynchronous client library since 5.5. So MySQL got this fairly recently in 8. There's also this idea of a limit rows examined, which basically the server counts the number of reads, inserts, anything that's modified and deleted rows during the query execution, takes into account the use of temporary tables, as well as sorting for intermediate query operations. Once the counter exceeds the values specified in the limit rows examined clause, in this case 1000, the query execution is terminated as soon as possible. It will tell you the results may be incomplete. And this optimization is to provide means to terminate the execution of a select statement which examines too many rows and thus uses too many resources. So extremely usable in very large environments where people do select stars, or you have to read from heaps of rows. It's been the enhanced kill syntax for quite some time, which allows you to kill the connection in a hard way, which is basically immediate. In a soft way, ensures that it won't leave tables in an inconsistent state that aren't interrupted, like repair or index creation for MySQL or Aria. You can also kill by username, also obviously via query ID, thread ID. So query ID is actually also a unique MariaDBism. So kill exists in MySQL, but it is extended in MariaDB. Also, you'll notice time to sec as well as Unix timestamps preserves microseconds in the argument. So here's another quick example of that. MariaDB still has a fairly interesting user enhancements. So for one, it allows you to have this user statistics, which came out of the Google and Facebook patches. So if you turn on site global user stat equals 1, you can run things like show client statistics, show user statistics, index statistics, as well as table statistics. So you'll find out the number of connections, CPU usage, bytes received, and so forth, as well as rows read, changed, as well as indexes. MariaDB since 10.2 has had a delete returning function, where delete operations that return a result set of the deleted rows to the client. So you can actually do things like delete post from blog, inner join post where blog ID equals post blog ID, and then do delete from T1 where A equals 2 returning asterisk. And this statement would basically join two tables. One is only used to satisfy a where condition, but no row is deleted from it. And then the rows from the other table are deleted instead. And delete returning is interesting because from 10.2 to 10.4, there have been no changes to delete returning, but in 10.5, you will start seeing the base of delete returning actually gives you other more interesting returning clauses. And this, if you are familiar from, say, a DB2 background, this is something that has been available there for some time. There are also many more MariaDB enhancements. For one, if you are using the query cache, so I think if you're still reliant on the query cache, which MySQL has actually more or less removed, you can actually continue using it in MariaDB if you wanted to. If you were using it, you can actually show the contents of the query cache via a query cache info plugin. So it actually will query the table acquiring the query cache lock. Lock waits for the queries using or expiring the query cache, and that's potentially useful if you're using it. But maybe the right answer is maybe you should continue disabling the query cache because you can't, make use of it like if you use a Galera cluster, and there are much more efficient ways to do this. If you want to see how long a query takes to execute, there is also the query response time plugin, which is quite handy. And this basically allows you to install and then do a show query response time. Slow query log will provide exact information for you about queries that take a long time to execute. So if there are a large number of queries that each take a very short amount of time to execute, you don't see that inside of the slow query log. So the query response time plugin actually gives you a tool for analyzing that information by counting and displaying the number of queries according to the length of time they took to execute. And I believe this is still available in Percona server for MySQL. But it is MariaDB, and it is also available in MariaDB, and quite happily still being able to use it. Now, another extension that will make more Oracle folk happy is that decimal is now 38 decimals are supported instead of just 30. Now, this is interesting because if you start using more than 30, if you try to go back to MySQL, even in a dump, this would cause problems. The ability to type show create user is very useful in MariaDB. If you want to know how this user was created, you can just type show create user and you will actually find out how said user was created. And you can actually more or less copy and paste said stuff to another server, and you can create user in a similar way. Shutdown wait for all slaves is to ensure that the last binary log event must be sent to all secondaries before shutting down. This is extremely useful from a perspective of wanting to make sure that all your secondaries have caught up before you turn off the primary. And then there's also show profile, which still works in MariaDB, so you can actually set profiling on, do select, and then do show profile to actually show you which files were opened and touched. So this is still being maintained. It is only being seemingly maintained in MariaDB, and yeah, well worth checking it out. There are, of course, differences. It wouldn't be, otherwise we wouldn't actually have a dedicated talk on MariaDB. For one, JSON in MySQL 5.7 and greater has a binary data type. MariaDB chooses not to implement it this way, not to violate the SQL standard, but there is a JSON text alias for compatibility. The optimizer is different enough that one can consider MariaDB Server and MySQL two very different databases. In fact, if you look at MySQL 8, the optimizer has been refactored quite tremendously. So that's worth considering. Encryption is also different. I mean, the way encryption has been enabled in the server, yes, encryption came first to MariaDB. It is also available in MySQL. MariaDB has things like key management plugin. So for Amazon KMS, we don't quite see, we do see that available inside of MySQL Enterprise, but not in the open source version. And this is a common question that comes up often. It's like, what key management solutions do you end up supporting? And Amazon's one is reasonably cheap to use. You need to get a credit card going. I know Percona has a Vault plugin. And MySQL's plugins are all more or less commercial. Except unless you want to use file key management, which is by itself not secure. The X protocol, if you happen to use it in MySQL 8, is not supported in MariaDB Server. So you can't use MySQL SH and you can't use the X protocol. So you have to query MariaDB via SQL only. When it comes to regular expressions, MariaDB implements Perl compatible regular expressions with multi-byte character set support, including East Asian sets. MySQL now implements the ICU, which is the International Components for Unicode, which also provides full Unicode and is multi-byte safe, as opposed to so both have replaced the Henry Spencer's regular expression library. But I guess MariaDB got here a lot earlier than MySQL. And Perl compatible regular expressions, you also have things like recursive patterns, name capture, look ahead, And every new bit of syntax that was introduced with MariaDB is also now available inside of MySQL. It is worth noting as well, if you've come from, say, Red Hat RHEL 7 or MariaDB 5.5, which recently only hit its end of life, is that InnoDB is no longer the extra DB that's available inside of MariaDB. That changed in 10.2. And more importantly, neither is InnoDB from MySQL. It calls itself InnoDB, but it is not InnoDB from MySQL. This is InnoDB from MariaDB with its own version. So when you do checking InnoDB version, you'll see that it actually matches the server variant. But if you're starting to look for InnoDB feature by feature, this is also a much harder comparison for you to then start making. MariaDB has a huge chunk of storage engines. MyRocks is available for write-intensive workloads. In fact, it is the Facebook fork of LevelDB. MyRocks is the interface to it for MariaDB. It's write optimized. So you focus on endurance of flash devices to gain better lifetimes because it has up to 10 times less write amplification compared to InnoDB. It's got better compression, which is at least two times. It's got the ability to load data fast, avoiding compaction overheads. Things like read-free replication so that there are no random reads for updating secondary keys, only for unique indexes. And it's got row-based bin log. It's an amazing tool that you could potentially start using. It's available inside and fully supported inside of MariaDB. It's also Spider, which is there for scalability and sharding via using SQL actually. So you can expect that Spider is a sharding solution that is built into MariaDB for the purposes of sharding. And to be very fair, Spider used to be an independent product. It is now also owned by MariaDB. InnoDB is obviously the default for read-write operations. I think all of you know InnoDB really well. Column store I've included here for completeness. It's there for analytical purposes. It is available in the Enterprise 10.4 release now as an integrated storage engine, but it will only appear in 10.5 for the the regular MariaDB server that we're all using. One very important thing to note is that system tables used to be stored in MyISAM in 10.4 and greater. It's stored in Aria now. Aria has been a storage engine that is referred to as a crash save MyISAM, and it's been around again for since the start of MariaDB. And now you need to actually configure Aria to make sure that Aria page cache size and so forth. OQGraph has the new leaves algorithm to return all reachable leaf nodes from a given origin, or all root nodes that can reach a given destination, requiring libjudy. This is not something I think many people use in production, but it is available. The partition engine is still around because it's definitely updated to make Spider work better. It's got numerous improvements, including full text support, multi-range read, which gives better performance when handling multiple ranges, support for condition pushdown to the storage engine, handler support, aggregate pushdown, as well as bulk updates and deletes. Cassandra storage engine is still around. I do not recommend that you use it because it connects to an old version like Cassandra. The Connect engine is very cool. It's great for ETL operations. You can read things like MongoDB BSON files and old access files and bring it into MariaDB. And there's also TalkyDB, which requires JMalloc and transparent huge pages to be on, but you don't actually need to basically use this any longer with MyRocks. Then there's the Oracle PL/SQL support, which is, I think, extremely cool, and I think not somewhere that we would see MySQL move to. Basically, there is a PL/SQL compatibility parser that is added for easier migration. There is the ability for you to put on SQL mode equals Oracle. In fact, 10.5 also has a MS SQL mode that's sort of available for testing purposes. All data types have synonyms in MariaDB. So like a varchar2 is varchar, numbers, decimal, and so forth. You have the ability to do things like cardinval, nextval, So if you're looking at the sequences, this is not to replace auto increment, where you can create an auto number field using sequences, whereas the sequence is an object in Oracle that is used to generate a number sequence, and it can be useful when you need to create a unique number to act as a primary key. So MariaDB supports ANSI SQL as well as Oracle syntax for sequences. Sequences are implemented in a special type of table, though. So it uses the same namespace as tables, and when you do show tables, you'll see the sequence, and also create a sequence with create table and then drop it with drop table. The only thing that is a negative here is that it's affected by a lock table, but all tools will work with sequences. There's also the ability to do things like execute immediate row data type for stored routines, cursors, packages. There is a lot of stuff inside that will give you, some say, up to 80% compatibility for Oracle applications to MariaDB. There is also invisible columns. Now, invisible columns allow you to remove a dependency to applications. So your columns can be added to tables with hiding them from the application, while others otherwise may fail to run. You can keep historical columns that are not needed by applications any longer. Prepare a database level for an upgrade before an application will be itself upgraded. Hide system created columns. And when you do, in this example, as you can see, do select star from, it won't show, but you have to explicitly specify what you want it to show. In this case, the secret. And of course, the insert statement doesn't require the value to be provided as well for an invisible column. So this could be potentially useful, again, from a migration standpoint. System version tables are an SQL 2011 standard. Stores history of all changes. It's great if you want to do forensic analysis or you have legal requirements to store data for N years. You can use it for data analytics, so retrospective trends, etc. Get information from 1 year ago. Point in time recovery, so you can recover a table state to a particular point in time. Timestamp versions of the data in the table. Also, you can allow track changes to compare database and timestamps, visualize the development cycle of data and to create trends, audit change of data. Also partition data by system time to, yes, got it. You can also partition data by system time to store separately historical data and current data, and you can also delete history. So you can make as of queries to select data as of a point in time. You can also do between and to select data between 2 points in time. You can also obviously partition data by system time, and time periods, of course, are defined as two ranges between two temporal columns. And we've got a bit of examples around this as well. So in this case, you've got creating table employees with system versioning. So you've got name, salary, department. You insert it into employee values. Colin earning $1,000, working in marketing. Now salary is updated to $10,000. And then is switched to the engineering department. And then you can actually select stuff from employees. When it was Colin, you will see that now is moved to the engineering department. And then you can go back in time and see all those changes that were made as well. So this is definitely quite handy when you want to go back in time. And if you want to know as of, so we can just select stuff from employees for system time as of a certain timestamp, which we noted from before, and you'll see that that was the original scenario. There is also Galera Cluster 4 inside of MariaDB 10.4. It actually is the high availability solution of choice for MariaDB Server. It supports streaming replication, group commit that's native to MariaDB. Also supports backup locks, and of course works with Mariabackup. It has SSD with lightweight backup locks. That is a MariaDB feature. So this is so streaming replication is new to Galera Cluster 4. So you can basically run transactions of unlimited sizes in a cluster. Previously, you'd use WSREP max WS rows and WSREP max WS size to limit transaction rows between 120 kilobytes, maybe up to 1 gigabyte, and WSREP max WS size was a maximum upper limit of 2 gigabytes, at which point anything larger than that was rejected. If you do a load data in file, so again, say a 10 gigabyte load data in file, what happens is transactions are replicated gradually in small fragments during transaction processing, i.e. before an actual commit. But Galera then replicates a number of small size fragments. This is transaction fragmentation. The size threshold for fragments replication is configurable, and you can replicate fragments applied in slave threads, preserving the transaction state in all cluster nodes, and the fragments will hold locks in all nodes and cannot be conflicted with later. So streaming replication allows nodes to process write sets much larger than 2 GB in size, and this is all configurable, runtime configurable via options available. And this is all fairly well documented as well. There is also the ability for you to look at new metadata tables inside of the MySQL database. There's the WSRep cluster option, WSRep cluster members to show you what the membership looks like, as well if you turn on streaming replication, what the streaming log is also going to look like. And then there are a bunch of new write set replication functions that you can actually implement in your application. WSRep last seen GTID will return the global transaction ID for the last written transaction observed by the client. WSRep last written GTID returns the global transaction ID of the last write transaction made by the client, and WSRep sync wait up to GTID blocks the client until the node applies and commits the given transaction. So Galera Cluster 4, extremely useful, extremely handy, been around in MariaDB 10.4 for basically a year now, and more exciting changes coming in Galera Cluster 10.5, in MariaDB 10.5 for Galera Cluster. If you come from a MySQL 8, it is worth noting that there are some gotchas. One is that GTIDs are different in MariaDB compared to MySQL 8, and MariaDB does not have GTID in the OK packet. So you were earlier in a proxy SQL talk where you can actually do some tricks when you read the GTID in the OK packet. You can't do that here with MariaDB. There's no X-Protocol support or MySQL SH support, as mentioned earlier. There's no group replication or InnoDB cluster. That might be a limitation for some of you because you may like MySQL SH to configure InnoDB cluster and group replication. Of course, there is Galera Cluster in MariaDB, but it's not the same as MySQL SH doing that. Performance schema comes from MySQL 5.6, which is kind of dated, which is why it's also turned off by default. There's no caching SHA-256 password. MySQL user password is stored in MySQL user authentication string. There is no set persist. Set persist is useful in MySQL 8 because you can make changes as you run, and then you can say set persist. There is also no native data dictionary in MySQL 8 has. There's no InnoDB self-tuning options that MySQL 8 also has. No invisible indexes. MySQL 8 has a temporary table storage engine, which is not present inside of MariaDB. There is no InnoDB native partitioning because the partition storage engine is still around inside of MariaDB. And there are no resource group support. So this is a compatibility thing that I think MySQL 8 people are probably potentially using. These are like high-level stuff that is not supported. But there are also so many things that MariaDB had, but not MySQL also still has. Like check constraints arrived in MySQL 8.0.16, I think. So it wasn't around in like every or 8 or 14. It wasn't around in every MySQL release, but it appeared after a GA. Common table, recursive common table expressions, window functions, just functionality been around again, ages ago. Then there are things like virtual columns, for example. They appeared in MariaDB ages ago, and then they showed up in MySQL as generated columns. The ability to reload SSL without restarting the server also MariaDB 10.4 and also appeared in MySQL. The ability to do instant add column is also something that you can see came actually from the 10 patches, and both in MySQL 8 and MariaDB 10.4. Roles came to MariaDB first, and then after that, next release was for default role, and MySQL also got it later. But then you also have the ability to do things like roles graph ML with MySQL. That's not possible inside of MariaDB. And there's things like backup stage for efficient backups that are also MariaDB only. So you're starting to see that I try to focus on everything that MariaDB had that maybe MySQL does not have, but there were so many other things that MariaDB also have has had, but appeared in MySQL later. So the syntax may be different. Sometimes implementation is of course different, but from a feature standpoint, it should be similar. Now we'll look forward to 10.5, which should be out, as I said, probably potentially even within the next month. You have like delete returning the ability to do things like insert returning as well as replace returning, which returns results out of the inserted rows. The ability to have additional new JSON functionality, which some people would find handy. The S3 storage engine allows you to archive MariaDB tables into Amazon S3 or any third-party public or private cloud that implements the S3 API, maybe like Minio. And you can use S3 tables as well as partitioned S3 tables that are fully discoverable. So to create a partitioned S3 table, the partition table and as well as the partitions can be directly used by another server that has access to the S3 storage engine. So this is kind of unique, and it should be fairly useful when you're starting to use column store as well. Super privileges are a lot more finer grained now. So you can, so when you're doing grants, even you should note that. MariaDB has become a lot more politically correct. For one, you don't do show master status any longer. You can do show bin log status, and instead of doing something like show slave status, you can do show replica status. Now, of course, the old stuff will still be maintained for backwards compatibility, but being more appropriate for our times is much better. Things like the InnoDB adaptive hash index is now turned off by default. There's lots of optimizations to InnoDB. And the one other thing that I find fairly interesting is the 5.7 performance schema got merged as well. So I quite like that. And other improvements like PCRE for regular expressions have been upgraded to like PCRE 2, so pro-compatible regular expressions 2. So yeah, lots more changes coming up in MariaDB 10.5, and this time next month it'll be a different story. A handful of resources that are available for you include the fact that there are the MariaDB versus MySQL feature comparison, as well as the MariaDB versus MySQL compatibility. They're extremely high level. Yeah, with that, I was already warned I was pretty much running out of time. So yeah, that's me. That's me saying thank you. I don't actually know how we do Q&A per se. Maybe we don't. Oh.
Colin, thank you.
Yep.
Thank you for your exciting talk.